We will see the concept of global and custom exception handling. Then we will try to understand in which scenarios we have to use global and custom exception handling, what are their benefits, and finally we will have a look into implementing global and custom exceptional handling with real world project called Flight Booking System using Spring Boot 3.0 and microservices. Global exception handling and custom exception handlings. These are the two approaches used in software development to manage and handle the exceptions, which are unexpected or exceptional events that occur during the execution of program. Global exception handling, also known as centralized exception handling. It involves defining a central mechanism to catch and handle exceptions that occur throughout the application. In this approach, a global exceptional handler is set up to intercept any unhandled exceptions, and it provides a consistent way to deal with them. So it acts as a safety net, preventing the program from crashing and allowing for graceful error handlings. We can use global exception handlings for several scenarios. For example, we want to log the exception details such as error message, stack trace, and any other relevant context information. And we want to say perform some actions like display this error message to the user, initiate error recovery procedures, or gracefully shutting down the application. This approach helps to maintain the overall stability and reliability for the system by providing a consistent and controlled way to handle the exceptions. Custom exceptional handling, on the other hand, involve handling exception at the specific point within the code where they are likely to occur. So developers explicitly define the try-catch blocks around the portion of code that are prone to raising the exceptions. This approach allows for more fine-grained control over exception handling, enable different action to be taken based on the specific exception type or context. By using custom exception handling, developers can handle exception in a manner appropriate for the situation. They can provide specific error messages, perform specific error recovery action, or propagate the exception to the higher level of the application for further processing. Custom exception handling is often used when different exceptions need to be handled differently or when a specific exception handling logic is required. You will be thinking now which one to use when should I go for global exception handling, when should I go for custom exception handling. So now let's understand this with some scenarios. Choosing between global and custom exception handling depends on some specific needs and the requirement of our application. So we can consider some of the factors while deciding which approach to use. So for global exception handling, point number one is consistent error handling. If you want to enforce consistent error handling throughout the application, global exception handling is a suitable choice. While for custom exception handling, specific exception handling logic is important. So when different types of exceptions require different handling strategies or specific recovery actions, custom exception handling is beneficial. For global exception handling, if for example in your application you are dealing with some sets of common exception scenarios that can be handled uniformly, for example database connection errors or network timeouts. In such scenarios, global exception handling provides a convenient way to handle such exceptions in a centralized manner, and it will be very useful. While if there are scenarios where we want to do some propagation, right? So we want to propagate the call to the higher level components or module for specific handling, custom exception handling will be useful. This allow for higher level code to have a better understanding of exceptions, and they will take the appropriate action. The another difference is from the application stability perspective. So global exception handling helps to maintain the application stability by preventing unhandled exceptions from crashing the program. While In case of custom exception handling, it is very useful from the code readability and maintainability perspective. So if you want to make code more readable and self-explanatory by explicitly documenting anticipated exceptions and their handling logic, custom exceptional handling is recommended. So it will help you to improve the code maintainability, and it will allow developers to easily understand and modify the error handling logic. I hope with this we have a quite better understanding in which scenarios we will go for global exception handling and in which scenario we will use the custom exception handling, right? Let's see what are the benefits of global and custom exception handlings. Global exception handling offers several benefits like centralized error handling. Global exception handling provides a centralized mechanism to handle exception. It will ensure the consistent error handling throughout the application. So it eliminates the need to handle exception at multiple places. So there is less chances of code duplication, and it will help in improving the maintainability. Preventing application crashes. Global exception handling acts as a safety net. So it will prevent an exception handle from crashing the application. It allows for graceful error handling, enabling the application to recover from exception and continue its execution or initiate appropriate error recovery procedures. Logging and debugging. Global exception handling often logging capabilities which allow developers to capture and log exception details such as error message, stack traces, and contextual information. This information is valuable for debugging and troubleshooting issues. And the final one is the enhanced user experiences. By catching and handling exceptions globally, developer can provide a more user-friendly experience by presenting meaningful error messages to the user. Custom exception handling also offers several benefits like fine-grained control. This allows developers to handle exception at a specific point in the code, providing granular control over exceptional handling logic. Context-specific error handling. This enables developer to handle exception in a way that makes sense for a specific situation. So for example, it may involve retrying an operation, rolling back a transaction, or taking some specific recovery action based on the business requirement. Exception propagation. This allows exception to be propagated up to the call stack to the higher level of application system. This enables higher level component or error handling modules to handle the exception more appropriately. Code readability and maintainability. By defining try-catch blocks around the code section that can raise exception, custom exception handling makes the code more readable and self-documenting. It clarifies which exceptions are anticipated and how they are handled, making it easier for developer to understand and maintain the code base. We will also use controller advice to define global exception handlings for our controllers in Spring MVC applications.
This is our flight booking application.
Now let's see how we
started with the flight service.
application.
Now let's see
For
some
this thing,
parts
I
for
am
global
using one
exceptional handling.
microservice called as to implement the global exception handling and custom exception handling. I have already defined a module called as flight service. This is a microservice, and for this microservice we are using Spring Boot 3.0 and the baseline version is Java 17. So inside this flight service I have defined first one controller. What does this controller do? This controller has one API called as getFlightByNumber. So this getFlightByNumber will query the information of flight based on the flight number, and it will return us the flight details. Okay, so this flight response will hold the flight detail object. So I will quickly show you all these things like inside this model I have defined this class called as flightResponse.java. This flight response will return us with the flight ID, flight number, what is the origin, what is the destination, what is the departure date, arrival date, total number of seats available in a flight, and how many seats are available out of this, and for this specific thing what is the cost for this flight. The flight controller is using the flight service API to go to the business layer, right? So from this controller layer, the logic will go to the business layer using this flight service. So inside this flight service, first we have defined this interface, which is the same name get flight by number, and it will return the flight response based on this flight number. So let's see the implementation of this class. So for this implementation, we have defined the business logic in this method. So what this information it will do, it will fetch this detail from the repository, and it will see if this flight is available, we are good enough. If it is not available, then we will use this method called as or else throw. Okay, so this all or else throw method will help us to add some custom exceptions. I have defined the flight repository as shown here. This is a normal interface which is extending the JPA repository, and JPA repository will take the two parameters. The first parameter is the entity parameter which we want to persist in our database, and what is the primary key for that thing. So we are using the long. So I will quickly navigate you to this flight class also. So this is my flight class, and I am using the Lombok library to generate getter and setter for our application. So as you have seen here, I am using this data annotation for this purpose. No argument constructor to define the default constructor, and all argument constructor to get all the arguments for this constructor. Along with that, we have a builder pattern to use this builder, and we have defined this class as an entity because we are using MySQL for data persistence, and we can define the table with the specific name here as flights. And for this thing we have to add one important entity here, like what is the primary key for this application. So we have defined this as a ID, and we want to use this as a generated value. So for that we have defined this strategy called as identity, and these are the information which are same as the flight response we have seen. So it will have the flight ID, flight number, origin, destination, departure date, arrival date, total seat, available seat, and the amount. It may happen that the flight number what we are requesting is not available in the database. So it's advisable to throw some exception. So in such scenario, we can define our own customized exception. So I have defined one exception called as flight service custom exception, which will take two parameters. The first parameter is the message, where we can define the custom message and the error code. So let's see this class. So for this thing, I have created one separate package called as exception inside this flight service, and here we have defined this class. So this class will take two parameters. The first parameter is the message, and second one is error code. And also you have noticed that this class is extending the runtime exception. As we want to get this specific information, we have defined in the flight repository a method called as find by flight number. Okay, and this will return us the flight which is an optional. Okay, now we will move back to our flight service IMPL class. So inside this flight service IMPL class, because of this optional thing, we are able to provide this utility called as or else throw. And here we will define our custom exception, and we will see also here the use case with global exception. So first let's define this class called as flight service custom exception. So this flight service custom exception will extend the runtime exception, and here we are defining the error code. So this will take a parameterized constructor with two arguments. The first one is the message, and second one is the error code. So this message we will pass to the superclass, which is the runtime exception class, and the error code what we are defining, we will configure and set this value here. After we have configured the flight service custom exception, we have to now define the way how we can utilize this flight service custom exception. So let's define one class in exception package called as flight controller exception handler class. This class is annotated with controller advice indicating that it handles exception across multiple controllers. It extends response entity exception handler, which is a convenient base class provided by Spring that already provides some default exception handling behavior. The exceptional handle annotation is used to specify that handle flight service exception method handle exception of type flight service custom exception. Let's try to understand the use case for flight service custom exception in our application. We will see this usage in the API get by flight number. We understood the importance of flight service custom exception usage. Let's go back to the flight controller exception handler class to understand handle flight service exception method. The method receives the thrown exception as a parameter name exception, allowing you to access the detail of exception. Inside the method, a new response entity object is created using its constructor. It takes two arguments. The first argument is an error response object constructed using the error response.builder method. The builder method is used to start building the error response object, and the error code and error message field for the error response objects are set using the values obtained from flight service custom exception object. The build method is called to create the final error response object. The second argument is http status.notfound, which represents the http status code to be sent to the response. In this case, it is set as 404 not found. Finally, the constructed response or entity object is returned, which encapsulates the error response object and the HTTP status code. And this response will send back to the client as a result of handling the flight service custom exception. By customizing the error response and HTTP status code based on the exception details, you can provide meaningful error response to the client, conveying information about the encountered exception in a standardized way. Our API now get by flight number is ready, as we have already defined a global exceptional handler called flight controller exception handler, and also we have defined the custom exception called as flight service custom exception, and as well we have seen this implementation in the flight service IMPL class. So here we are invoking this method. So now let's try to verify our controller for this API. So we will start our services and we can verify. Now let's run our application again. And in the Postman we can verify this API. So let's define this endpoint and click on send option, and we can see we are able to see the response. Now let's verify by providing some wrong input, let's say 404, and send this exception. So here we can see the error message with the information what we have provided, flight with given number not found, and with the error code flight not found. So now you can see how simpler it is, easy to see this error message and error code irrespective of getting such a big exception, isn't it? So the customized exceptions are really very useful to show the error messages in a standard way. As we have seen previously that we have implemented controller advice for this class flight controller exceptional handler, which is extending from the response entity exceptional handler, right? And we have seen with some invalid request also, like if we are passing some data which does not exist, we are getting the error message flight with given number not found and the flight not found. Now let's see another usage. In the flight service IMPL class, let's try to comment this part and add here the get method. and we will see what happens, what kinds of exceptions we are observing. And to restart our server, let's add the dependency. From the Spring Initializer, find the dependency Spring Boot Dev. Just click on this one, go to the Explore section, and from here copy this dependency. Close this one. And before this test, we will add this dependency. Say yes. We will restart this time. Afterwards, we don't have to restart service application. So from here, just run the application again. The service is now up and running. Now let's go to the Postman and hit a send message. As you can see here, there is a big message, internal server error, with the entire stack trace, right? It's too huge message, as you can see. So this is the reason we have to implement the generic exception handler. I hope this has given you a clear understanding why we need the global service exception. We have already implemented flight service custom exception. Now let's implement the generic exception. So in any case, if we do not have the custom exception, still we will not get this big message, but we will get the specific message. We already have defined this class flight controller exceptional handler. Inside this class, let's add another method which will handle the generic exception. So inside this exceptional handler, we will provide the parameter as exception.class instead of any custom exception, and inside the return message we will provide the error code as internal server error and the status code also as internal server error. And the method name, we can define this as a generic exceptional handler. Rest of other details are quite similar. Inside this flight service IMPL class, now let's uncomment this part. And we will remove the get method from here. Along with that, instead of this custom exception, we will throw the runtime exception. And runtime exception does not take two parameters, so let's remove this another parameter and save it. Now inside this Postman API, let's try to hit the record which is not available. And we can see the message flight with given number not found with internal server error code. And here also we can see the status as 500 internal server error. Now let's try to give with some valid records. EK402 is available, so click on this send when and we are able to see the record. Again, if we are trying to hit with the flight which is not available, we will get the error message as flight with given number not found with the error code and status also as 500.
Thank you for watching. If you have not subscribed, please subscribe it.